In the vast expanse of our solar system, there's a tiny world that dances closer to the Sun than any other planet. This planet, often overlooked due to its size and proximity to the Sun, plays a crucial role in the cosmic ballet. This celestial wanderer, often lost in the Sun's glare, is Mercury. Named after the Roman messenger god, it zips around the Sun with incredible speed. Don't let its size fool you. This little planet holds big secrets. Its surface is a testament to a violent past, marked by countless craters and ancient volcanic activity. Mercury is a fascinating world of extremes. Temperatures can swing from scorching hot during the day to freezing cold at night, making it a planet of stark contrasts. It's the smallest planet in our solar system, even smaller than Jupiter's moon, Ganymede. Despite its diminutive size, Mercury's density is second only to Earth, but what it lacks in size, it makes up for in speed and surprises. Mercury completes an orbit around the Sun in just 88 Earth days, making it the fastest planet in our solar system. Mercury's proximity to the Sun makes it a challenging target for observation from Earth. Its elusive nature has made it a subject of intrigue and mystery. Yet, throughout history, this elusive world has captivated astronomers, sparking curiosity and igniting our imagination. From ancient civilizations to modern-day scientists, Mercury continues to be a source of wonder and discovery. Mercury races around the Sun at an astonishing speed, completing an orbit in just 88 Earth days. That's less than 3 months on Earth. This swiftness earned it the nickname the Swift Planet, a fitting title for such a fast-moving celestial body. Imagine that. A year on Mercury is shorter than a season on Earth. While we experience winter, spring, summer, and fall, Mercury completes a full orbit. This incredible speed is due to Mercury's close proximity to the Sun. Being the closest planet to our star, it feels the Sun's gravitational pull more intensely. The Sun's powerful gravity pulls Mercury along, sending it hurtling through space like a stone flung from a cosmic slingshot. This immense force keeps Mercury in its rapid orbit. As Mercury zips around the Sun, it doesn't move in a perfect circle. Its path is more complex. Instead, its orbit is elliptical, more like an oval. This shape causes variations in its speed and distance from the Sun. This means that Mercury's distance from the Sun changes throughout its year. At times, it is closer, and at other times, it is farther away, creating a dynamic and fascinating journey around our star. Mercury's close relationship with the Sun comes at a price. Extreme temperatures. During the day, the surface of Mercury can reach a searing 800 degrees Fahrenheit. That's hot enough to melt lead. But here's the twist. At night, without a substantial atmosphere to trap heat, Mercury's surface temperature plummets to an unimaginable minus 290 degrees Fahrenheit. Talk about a temperature swing. This dramatic temperature variation is one of the most fascinating things about Mercury. It highlights the powerful influence of the Sun and the importance of an atmosphere in regulating a planet's climate. For decades, Mercury remained largely shrouded in mystery. But thanks to robotic emissaries like NASA's Messenger spacecraft, we've started to peel back the layers of this enigmatic world. Messenger spent years orbiting Mercury, capturing stunning images and collecting valuable data. It revealed a world scarred by ancient impacts, with a surface resembling our own moon. These missions also discovered something unexpected: evidence of water ice hiding in permanently shadowed craters at Mercury's poles. This finding was a game changer, suggesting that even the most unlikely places in our solar system might harbor the ingredients for life. Section 5. A thin veil. The elusive atmosphere of a celestial wanderer. Unlike Earth, with its life-sustaining atmosphere, Mercury possesses an incredibly thin atmosphere, almost non-existent. This thin veil is known as an exosphere, a term that highlights its tenuous nature. This exosphere, as scientists call it, is made up of atoms blasted off the surface by solar wind and micrometeoroid impacts. These particles are so sparse that they rarely collide with each other, creating a ghostly presence around the planet. This wispy shroud offers virtually no protection from the sun's intense radiation or the impacts of space debris. The lack of a protective barrier means that Mercury is constantly bombarded by high-energy particles from the sun. It's as if Mercury is constantly exposed to the harsh realities of space. The planet's surface bears the scars of this relentless exposure, with craters and cracks marking its history. The lack of a substantial atmosphere contributes to Mercury's extreme temperature swings. During the day, temperatures can soar to scorching highs, while at night they plummet to freezing lows. It also allows meteoroids to reach the surface unimpeded, leaving behind a heavily cratered landscape. These impacts have shaped Mercury's surface over billions of years, creating a rugged and ancient terrain. One of the most intriguing mysteries surrounding Mercury lies deep within its core. This metallic heart is unusually large for a planet of its size, making up almost 85% of its radius. Scientists are still trying to understand how Mercury's core grew to be so massive. Some theories suggest that early in its history, Mercury might have been much larger. A catastrophic collision could have stripped away its outer layers, leaving behind the dense, metal-rich core we see today. Understanding the formation and evolution of Mercury's core could provide valuable insights into the processes that shaped our entire solar system. In 1974, humanity caught its first glimpse of Mercury's surface thanks to NASA's Mariner 10 spacecraft. This pioneering mission flew past Mercury 3 times, snapping the first close-up images of this enigmatic world. The images sent back by Mariner 10 were grainy and black and white, but they revolutionized our understanding of Mercury. They revealed a heavily cratered surface, resembling our own moon, and confirmed the existence of a tenuous atmosphere. Mariner 10's flybys were brief, but they paved the way for future missions, like Messenger, to delve deeper into Mercury's secrets. Despite its small size, Mercury surprised scientists by possessing a global magnetic field. This magnetic bubble, though much weaker than Earth's, acts as a shield, deflecting charged particles from the solar wind. The discovery of Mercury's magnetic field was unexpected. Scientists are still trying to understand how such a small planet can generate and sustain a global magnetic field. The presence of a magnetic field on Mercury suggests that its core is at least partially molten, creating a dynamo effect similar to what generates Earth's magnetic field. Studying Mercury is like looking back in time. Because it's so close to the Sun and has remained relatively unchanged for billions of years, Mercury can teach us about the early solar system and the processes that shape the inner planets. By unraveling the mysteries of Mercury's formation, composition, and evolution, we gain a deeper understanding of our own planet's history and the forces that shaped our cosmic neighborhood. Mercury may be the smallest planet in our solar system, but it holds enormous potential for unlocking some of the biggest secrets about our cosmic origins.